In this video, we will learn about recursion. Put simply, recursion is when a function calls itself. Up until this point in the course, we've learned how to solve problems iteratively, using iteration with for loops and while loops. In order for a function to be recursive, it needs to have the following properties. The function needs to call itself, it needs to have at least one base case, and each call to the function needs to progress closer to the base case. I mentioned an important term in the second and third points, base case. A base case is a condition that causes the function to terminate, in other words, to stop calling itself. Without a base case, the code will execute indefinitely. Each recursive call gets stored on the call stack, and since the call stack has a finite amount of memory, it eventually runs out and will throw a Stack Overflow exception. Fun fact, this is what the programming help website Stack Overflow is named after. Let's look at some examples of working with recursion using C++ hands-on. We'll start out with a basic example and work up through more advanced code. To start off, let's use recursion to create a program that gives us the factorial for a number. For those unfamiliar with the term, a factorial is when we multiply a number by all the numbers less than it. For example, 3 factorial is 3 times 2 times 1, which makes 6. 4 factorial is 4 times 3 times 2 times 1, or 24, so on and so forth. Let's create a function that returns an integer, which we will name factorial. Our factorial function will take in one parameter of type int, named num. Inside of this function, we will check if num is greater than 0. If so, we will return num times the result of a call to the factorial function, with num minus 1 passed in. Else, we will return 1. That wraps up our factorial function. The next step is to go inside of C++'s main function. We will output the result of a call to our factorial function with 4 passed into the console. When we run the code, notice that 24 was output, which is the correct answer for 4 factorial. If we change the number passed into the factorial function to 3, notice that 6 is output, which is the correct result for 3 factorial. The next example of recursion we will look at is slightly more complex, and if you studied computer science in college, you will almost certainly be familiar with it. It is the Fibonacci sequence. The pattern starts with the number 1, and is formed by adding the prior 2 numbers in the sequence to it. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 13 plus 8 is 21, so on and so forth. How would you code this algorithm recursively using C++ code? We'll start out by creating a function that returns an int named fib, which takes in one parameter of type int named n. Inside of this function, we will use an if statement to check if n equals 0 or n equals 1. If so, we will return 1. These are our base cases. Else, we will return fib with n minus 1 passed in, plus fib with n minus 2 passed in. Inside of the main function, let's test our code. We can output the result of fib3 to the console. When we run the code, notice that the correct output of 3 was printed. Changing the argument passed into the fib function to 7, and then running the code results in 21 being output. Great, our fib function works properly. Let's look at another popular example of recursion commonly taught in college, the Tower of Hanoi. Before we jump into coding a solution, let's open up a web browser and navigate to mathsisfun.com/games/towerofhanoi.html to see an interactive version of this challenge. Tower of Hanoi is a puzzle that features 3 towers, or pegs. There are discs of various sizes, from smallest on top to largest on the bottom. The objective of this game is to move all of the discs to Tower 3, with the rule that we cannot place a larger disc onto a smaller disc. We want to do this in the least amount of moves possible. For example, given 3 discs, we can move the small disc to Tower 3, then the medium disc to Tower 2, the small disc to Tower 2, the large disc to Tower 3, the small disk to tower 1, the medium disk to tower 3, and the small disk to tower 3, on top of the other two, to solve the puzzle. Let's create a function with a void return type named Tower of Hanoi. It will take in a parameter of type int named n, a parameter of type char named from, a parameter of type char named to, and a parameter of type char named extra. First, we need a base case. If n equals 0, we will return from the function. After that, we will make a recursive call to the Tower of Hanoi function with n-1 passed in as the first argument, from passed in as the second argument, extra passed in as the third argument, and to passed in as the fourth argument. Next, we will output move disk, then the number of the disk n, then the word from, then the from disk, then the word to, then the to disk, and then endl, aka the new line. Then we will make another recursive call to the Tower of Hanoi function and pass in n-1 as the first argument, extra as the second argument, to as the third argument, and from as the fourth argument. That wraps up the Tower of Hanoi function. The next step is to go inside of C++'s main function and test it. Let's create an int variable named n that we set equal to 3. Then we will call the Tower of Hanoi function with n passed in as the first argument, the character 1 as the second argument, the character 3 as the third argument, and the character 2 as the fourth argument. After that, we will run the code. Notice that the steps to solving the puzzle are printed to the console. Great, our code worked. Let's run another test. This time we will change n from 3 to 4. Then we will run the code, and you'll see the steps correctly printed for when there are 4 disks. Great work.